So here's a lesson about number patterns or number sequences. 5, 8, 11, 14. So what's the next number in the sequence? Maybe you can see a pattern that it's plus 3 every time. So you'd expect the next number to be 17. Now what's the 10th number in the sequence? That's a little more difficult. If you keep on adding 3's every time, you'll eventually get to 32. So 5, 8, 11, 14, 17, 20, 23, 26, 29, and 32. But what about if you want the 1000th number in the sequence? Well, that's a lot more difficult. You certainly don't want to have to work out the previous 999 terms, so it would be good to have a rule that gives the 1000th term directly. And that's what this topic is all about, finding a rule that helps you to establish numbers in sequences. So we can put the numbers in a table. So we've got the position in the sequence, so 1 for the first number, 2 for the second number, 3 for the third number, and so on. And then the first number is 5, so I say the first term is 5, the second term is 8, the third term is 11, the fourth term is 14, and so on. And all of these are the nth term, where n is the position in the sequence. So every time these go up by 1, the position in the sequence, we notice in this case that the terms themselves go up by 3, and that gives us a big clue that if there's a rule for this, the rule for the nth number involves 3 times n, because these numbers are going up 3 times as fast as these numbers. But if the rule was just that the nth number is 3 times n, then we'd get the wrong numbers, because when n is 1, 2, 3, 4, or 5, we'd get 3 times n would be 3, 6, 9, 3 times 4 is 12, 3 times 5 is 15. So it's not quite the right numbers. We want the numbers 5, 8, 11, 14, 17. That was the sequence. So we've got a set of numbers that is going up by 3 every time, but it's not the right set of numbers that are going up by 3 every time, because these are, well, the ones we're getting are too short or too small by 2. So if we add 2 to all of these, we're going to get the numbers that we actually want. So the rule must be not 3n, but 3n plus 2, and then we do indeed get the numbers that we want. So now that we know that the rule is the nth term is 3n plus 2, and then it's easy to work out the 1000th term, because you just say that if the nth term is 3n plus 2, then the 1000th term must be 3 times 1000 plus 2. You just stick 1000 in instead of n. 3000 plus 2 is 3002. And you didn't need to calculate the previous 999 terms in order to figure out what the 1000th term was going to be. Okay, so here's some examples. 16, 18, 20, 22. What is the next number in the sequence? What is the rule for the nth term? What is the 1000th number in the sequence? So I'd like you to just pause the screen there and see if you can figure that out before you go ahead and look at the answer. Okay, so here comes the answer. So we can make a table of the values, so 1, 2, 3, 4, 5, and so on for the first term, the second term, the third term. And we notice that the numbers are going up by 2 every time, so that gives us a big clue that 2n might be involved with the rule. So if we do 2 times n, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so on. We get 2, 4, 6, 8, 10, 12, 14, and so on. So we're getting numbers that go up by 2 every time, but they're not the right numbers, because we want 16, 18, 20, 22 as the sequence. So we need to add 14 to all of these, and then if we add 14 to 2, we'll get 16. If we add 14 to 4, we'll get 18. So we can see that we're short by 14, so we need to add 14 to all of these. So the rule is not 2n, but 2n plus 14. The nth term is 2n plus 14, and then we do indeed get the numbers we want: 16, 18, 20, 22, 24, 26, 28, and so on. So the next number in the sequence was 24. The rule for the nth term was that the nth term is 2n plus 4, and then the thousandth number in the sequence, you just apply 1,000 to that rule, so 2 times 1,000 plus 14. Did I say 4 before? 14 I meant. And you get 2014. Example 3. What is the next number in the sequence? What is the rule for the nth term? What is the 347th number in the sequence? So again, pause the screen before you look at the answer. Try and figure it out first. So here comes the answer. So we can make a table with 1, 2, 3, 4, 5 for the position in the sequence again. We notice that the numbers are going up by 5 every time. So that gives us a clue that there might be 5n somewhere in the rule. But if we do 5n, then we get 5, 10, 15, 20, 25, 30, 35, and so on. So 5 times wherever you are in the sequence gives us that. But the numbers we want are not 5, 10, 15. They're 95, 100, 105. So it's going up by 5 every time, but it's not big enough. So we need to add something to all of these to get 95, 100, 105, and so on. So if we add 90, then we get the right numbers. So the rule is 5n plus 90. So to answer the question, 115 is the next number. The rule for the nth term is 5n plus 90. And then the 347th number, you just need to stick 347 in for n in that rule, and you get that the 347th term is 5 times 347 plus the 90 gives you 1,825. Okay, so on to question 4. Once again, pause the screen and try and do the question first before you look at the answer. So here comes the answer. This time, well, we can make a table again like before. This time the numbers are going down by 4 every time. So that gives us a clue that the rule must have something to do with minus 4n. So if we do minus 4 times 1, we get minus 4. Minus 4 times 2, we get minus 8. Okay, so we get a bunch of numbers that does indeed go down by 4 every time, but they're not the right numbers because we're getting minus 4, minus 8, minus 12. We want 88, 84, 80, and so on. So we need to add something to all of these in order to make them the same as these. So what do we need to add to minus 4 in order to get it up to 88? Well, we need to add 92. So if we add 92 to everything, we get the right numbers. And the rule is that the nth term is minus 4n plus 92. So answering the questions, the next number in the sequence was 72. The rule for the nth term was that the nth term is minus 4n plus 92. And then the 500th number, so you just need to stick 500 into that formula, and it comes to be minus 1,908. On to the next. Okay, so you can see the sequence there. We're looking for the 100th number in the sequence. So once again, pause the screen before you look at the answer. So here comes the answer. So it's going down by 6 every time. So that gives you a big clue that there's a minus 6n somewhere in the rule. If you do minus 6n, you get minus 6, minus 12, minus 18, minus 24. So you do get numbers that go down by 6 every time, but they're nowhere near the numbers we want. So what we need to do is add something to all of these in order to make them match up with all of these. So the number we need to add on this occasion is 781. So obviously you need to add the first one. If you add 6, it gets it up to 0, but then you need to add 775 to get it up to 775. So in total you're adding 781. So all of these you're adding 781 to get up to the number you want. And the rule is that the nth term is minus 6n plus 781. So answering the questions, the next number was 757. The rule for the nth term was that the nth term is minus 6n plus 781, as I said. And then the 100th number, so just stick 100 in that rule, and it comes out to be 181. Example 6. So again, pause the screen, have a go at the question, and then the answer's coming now. Okay, so making a table like that as before, we can see the numbers are going up by 1.2 every time. So that gives us a clue that 1.2 times wherever you are in the sequence is something to do with the rule. So if the rule is just 1.2 times the number in the sequence, you get 1.2, 2.4, 3.6, 4.8, 6, 7.2, 8.4. So you do get numbers that go up by 1.2 every time, but they're the wrong numbers because we want 10, 11.2, 12.4, and so on. So there's something that we need to add to all of these in order to get these ones. So what do you need to add to 1.2 in order to get up to 10? Or in other words, what's 10 minus 1.2? So the answer is you need to add 8.8. So the rule is that you need to add 8.8 to all of those, and then you get 1.2n plus 8.8. So answering the question, the next number in the sequence is 14.8. The rule for the nth term is that the nth term is 1.2n plus 8.8, and then the 824th number in the sequence, just stick 824 into that rule, and it comes out to be 997.6. Question 7. Again, pause it, have a go at the question, and then have a look at the answer after you've tried it. Okay, so making a table for the values, we can see they go up by 0.5 every time. So that gives us a clue that the rule has something to do with 0.5n. But if the rule was just 0.5n, then we'd get 0.5 times 1 is 0.5, 0.5 times 2 is 1, 0.5 times 3 is 1.5. So we'd get a set of numbers that does go up by 0.5 every time, but not the right set. So we need to add something to all of these in order for them to match all of these. We need to add 2.5. So if you add 2.5 to all of them, then you get the right sequence. So answering the question, the next number is 5. The rule for the nth term is that the nth term is 0.5n plus 2.5. And then the 600th number, just stick in 600 to the formula, comes out to be 302.5. Okay, here comes, I think, the last one. Okay, so 10.3, 10, 9.7. Again, pause the screen, have a go at the question. Okay, so here comes the answer. So it's going down by 0.3 every time. So when we make our table, that's giving us a big clue that the rule must involve somewhere in it 0.3 times where you are in the sequence. So if we do 0.3 times where you are in the sequence, we do get a set of numbers that goes down by 0.3 every time, but it's the wrong set of numbers. We're getting a set that starts with minus 0.3, but we want a set that starts with plus 10.3. So we need to add 10.6 to everything in order for the numbers to match. And then when we do that, the numbers do indeed match up. The next number in the sequence is 9.1. The rule for the nth term is that the nth term is minus 0.3n plus 10.6, and then the 4689th number in the sequence, so you just need to stick 4689 into that rule, and that's what it comes out to be, minus 1396.1.